Geometric series. A geometric series is created by adding the terms of a geometric sequence. So for example, if we have 2 plus 6 plus 18 plus 54 plus ... we can see that the common ratio is 3. So to get from 2 to 6, we're multiplying by 3. From 6 to 18, we're multiplying by 3. And from 18 to 54, we're multiplying by 3. So the common ratio is 3. And to find the sum of a series, A1 plus A2 plus A3 plus A4 plus ... we consider a sequence of partial sums where S1 is equal to A1, S2 is equal to A1 plus A2, S3 is equal to A1 plus A2 plus A3, S4 is equal to A1 plus A2 plus A3 plus A4, and Sn is equal to A1 plus A2 plus A3 plus A4 plus ... up as far as An, whatever the last term is. So it's very similar to arithmetic series. The only difference is that we have a common ratio instead of a common difference, but the concept is the same. It's where you're adding the terms. To create a formula for Sn, we do the following. So Sn is equal to A, so the first term, plus AR, so it's the first term multiplied by the common ratio, plus AR squared, so it's the first term multiplied by the common ratio multiplied by the common ratio again, plus ... plus AR to the power of n minus 3, plus AR to the power of n minus 2, plus AR to the power of n minus 1, and finally up as far as AR to the power of n. So if we were to multiply every term in that original sequence there by or, so we have Sn multiplied by or, so I have a dot there to represent multiply. Then A multiplied by or becomes AR, and AR multiplied by or becomes AR squared, and so on. And again, we keep going until we get to AR to the power of n. So the last term in the above sequence was AR to the power of n minus 1, but multiplying that by n, we get AR to the power of n. Now if we subtract, so that's a subtraction symbol there I've drawn in. So now we're going to subtract. So we're going to have Sn minus or Sn. So Sn minus or Sn. I got rid of the dot there. I just have them stuck together to indicate that they're being multiplied. So we're subtracting. So if we subtract the bottom line on the left from the top line on the left, we're going to do the same on the right hand side. So we're going to subtract this bottom line from the top line on the right hand side. So the ARs will cancel. The AR squareds will cancel. The AR to the power of n minus 3 will cancel. The AR to the power of n minus 2 will cancel. And the AR to the power of n minus 1 will cancel. So what's left? So we have an A and we have an AR to the power of n. So we bring down the A. We bring down the plus AR to the power of n. Don't forget your plus. And then we factorize both sides. So on the left-hand side, we can see Sn as the highest common factor. So we get Sn times 1 minus or. So we're just factorizing. And on the right-hand side, we can see we have A is the highest common factor. So we have A times 1 plus or to the power of n. And then we divide both sides by 1 minus or so that we can solve for Sn. So we divide both sides by 1 minus or so that we can solve for Sn. And then we're left with A times 1 plus or to the power of n all over 1 minus or. So this is our formula, our Sn formula for the sum of series of a geometric sequence. And this is given in the formula book. No need to learn it off, but the previous slides are just showing you the proof behind it, so showing you why this makes sense. So it's given in the formula book, no need to learn it off. So there's the formula book, page 22, and there's your formula. So Sn is equal to A times 1 minus or to the power of n all divided by 1 minus r, where a is the first term and r is the common ratio. So remember, this is just for geometric sequence. The formulas for the arithmetic sequences and series are above, so just make sure that you don't mix them up. Okay, so example 1, find term 5 and S5, so the sum of the first 5 terms of each of the following. So part 1, 1 plus 3 plus 9 plus ... So I'm just going to write out my sequence. So 1 plus 3 plus 9 plus ... I label 1 as A, the first term, and I'm going to work out the common ratio. So we can see I'm multiplying by 3 each time, but just to confirm, divide the second term, which is 3, by the first term, which is 1. So T2 over T1, giving me 3 over 1, which is 3. Then I take my formula for Tn from the formula book, because remember, I'm interested in finding T5 first of all. So Tn is equal to A times r to the power of n minus 1. So this is specifically for a geometric sequence. Don't mix it up with the formula for the arithmetic sequence. So for a geometric sequence, this is the formula. It's from the formula book. So the question asks for T5. So T5, we replace the n with 5. We replace the A with 1, because that's our first term with brackets. We replace the r with 3, because that's our common ratio with brackets. And n minus 1 becomes 5 minus 1 for the power. And into the calculator, you end up getting 81. So the fifth term of the sequence is 81. Now, that should have a 1 there, so 81. So if you kept multiplying by 3 each time, you'd eventually get to 81 for the fifth term. Okay, so now to find S5, so the sum of the first 5 terms. So we're going to use our Sn formula from the formula book. So that's A times 1 minus r to the power of n all over 1 minus r. So no need to learn it off. It's in the formula book. Subbing into the formula book. So we're looking for S5. So we swap A for a set of brackets and put 1 into it. We swap both of the r's for 3, and the n is now 5. So we've 1 multiplied by 1 minus 3 to the power of 5, divided by 1 minus 3, which gives 121. So the sum of the first 5 terms is 121. Just be careful inputting into the calculator, because it is a little bit messy and there's a fraction. Part 2, I'm going to just write out my sequence. 1 plus a quarter plus 1 over 16 plus ... So again, I want to find T5 and then S5. So A, I'm going to label as 1. So my first term is 1. So A is 1. I'm going to multiply by a quarter to get to the next term. So a quarter is my common ratio. So I can say term 2 divided by term 1 is a quarter divided by 1, which is a quarter. So my common ratio is a quarter. For Tn, I have A times r to the power of n minus 1. This is from the formula book. Remember, again, this is for a geometric sequence for Tn. Don't mix it up with the arithmetic sequence Tn formula. Subbing into the formula, for T5, I have 1 multiplied by a quarter to the power of 5 minus 1, which gives me 1 over 256. Therefore, the fifth term of the sequence is 1 over 256. For Sn, I have the formula A times 1 minus r to the power of n all over 1 minus r. So again, from the formula book, specifically for geometric sequence. Again, don't mix it up with the Sn formula for an arithmetic sequence. Subbing into my formula for S5, I have 1 multiplied by 1 minus a quarter to the power of 5, all divided by 1 minus a quarter, which gives me 341 over 256. Therefore, the sum of the first 5 terms of the sequence is 341 over 256.